Okay, so a manufacturer makes shoes to sell internationally. The manufacturer is contracted to make shoes for Egypt and Brazil. All right. So there is an interquartile range given, and there are complementary and combined events. This is basically a formula sheet. Interquartile range is basically the maximum value. As you know that the max value divided by the minimum value is called the range, right? The interquartile range is essentially the range between two quartiles, like Q3 and Q1. Complementary, independent, and combined events. This is related to sets and Venn diagrams. Now, you have learned all of this, but you're not supposed to know it in this way. They make it very difficult to understand. All right, so you don't have to know it in this specific method. Now, what does the question say? The box plots show the size of shoes sold in Egypt and Brazil. The distribution shown in the box plots are based on the medians and quartiles of the shoe sizes. Now have a look. The maximum shoe size that has been sold in Brazil is 45. The minimum shoe size that has been sold in Brazil is 38. The median shoe size that has been sold in Brazil has a size of 41, and the median shoe size that has been sold in Egypt has a size of 40. So, question number 2 says compare the sizes of shoes sold in the two countries. Now, most of the time, this sort of a question, you are supposed to be giving a qualitative analysis. Do you know what a qualitative analysis is?
Not really.
Qualitative analysis is when you talk about a specific thing without mentioning its quantity or without going into extra details. Okay?
All right.
So, you can talk about general things. So, any, uh, answer here would make more sense. So, for example, I can say that range. Now, I talked about range. Range is basically the maximum minus minimum value. In the case of Egypt, the range is 43 minus 37, which is of 6. In the case of Brazil, it's 45 minus 38, which is essentially 7. So I can say that the range of Brazil is more compared to Egypt, and Brazil should be capital B has a higher range. All right, so that's how we write it.
All right.
Then it says determine the range of shoe sizes required for manufacture. Now, this question is specifically talking about the general range. It's not talking about Brazil or Egypt or any specific country. So that's talking about general range. So the maximum possible value that we had was 45, as we can see here. And the minimum possible value that we had was 37. So if we subtract 37 from 45, we get an answer of positive 8. So that could be the value of the range. So in 4 minutes, in 4 to 5 minutes, we're done with 4 marks. We should always make sure that the number of marks that we are getting is equivalent to the number of minutes that we take uh, per question or per exam or whatever. Okay, let's move
All right.
forward. The manufacturer makes shoes in two factories, one in Egypt, one in Brazil. The factory in Egypt makes 60% of the shoes and 10% are defective. Okay. The factory in Brazil makes the rest of the shoes and 5% of defective. Oh, okay. The information is illustrated in the tree diagram. Sure. So we are supposed to find a specific value here. Now, as you know, when we were studying the tree diagrams, we should know that a total branch of a tree diagram adds to give us an answer of 1, right? Adds to 1. So I know something for a fact, and that is that whatever value there should be for Brazil, it should add up to give me a value of 1. So if I write 1 minus 0.6, I get an answer of 0.4. So here you go. The number of shoes being made in Brazil is going to be 0.4. Now, if they were made in Brazil, the chances of it being defective were 0.05. So the chances of them not being defective is going to be 1 minus 0.05. Can you tell me what value do we get in this case?
From the 1 minus 0.05?
Yep, I think it's going to be 0.95.
Yeah.
Okay, sure. So that value is essentially 0.95. So this is what we're done with in the tree diagram. Now, here comes the main question. Find the probability that a shoe chosen at random from either factory is defective. So what's the condition? That the shoe needs to be defective, regardless of what factory it is from. So it can be defective in two ways. It can be defective in two ways. The first method of it being defective can be this one. And the second method of it being defective can be this one. So what do we do in this case? We simply take individual probabilities first. So the probability of it being defected in Egypt, and then we take the probability of it being defected in Brazil, and then we add both individual probabilities. So we get 0.6 multiplied by 0.1, that gives us the value 0.06. Then the probability of it being not defected, that is, sorry, defective in Brazil. So that is 0.05 multiplied by 0.4. And that gives me the value of, I think, 0.02. Once we've done this, what we're supposed to do is we're supposed to add both of these individual probabilities. So 0.06 plus 0.02 gives us 0.08. This is the most difficult type of a question that you can have while solving probability. It won't get more difficult than this, hopefully. All right?
All right.
Okay. So, this was question number 2. Now, question number 3. Given that a straight line L1 has equation 2y minus 1 over 2 equals x, show y as the subject by rearranging the equation for L1. Okay, this type of question is more like the combination of algebra and coordinate geometry. But in case if someone did not study coordinate geometry or has a weak coordinate geometry, they should still be able to solve this question, as this question revolves around algebra as well. So we're supposed to show y as a subject of equation. Let's do it. 2y minus 1 equals to 2x. 2y equals 2x plus 1. Y equals 2x plus 1 combined over 2. Now, if someone was to write it up till here, that would have been fine as well. But this wouldn't have given us the final answer because 2 can be divided by 2. So I can write this as y equals 2x over 2, that becomes x, plus 1 over 2, which becomes 0.5. Or I can also write it as 0.5 directly. Decimal makes sense. Another straight line L2 has the equation this: y equals x plus 5 over 2. Find the coordinates of point of intersection between L1 and L2. This is something that we did in simultaneous equations. In simultaneous equations, we talked about coordinates of point of intersection. So, this line can also be written as x over 2 plus 5 over 2. And I know that y is the subject of both lines. So, I can say x over 2 plus 5 over 2 equals x plus 1 over 2. Because I've essentially what I've done is that I've equated both y's to each other. Okay, then what? Then we try our best to make x the subject of equation. So I can write this as 5 over 2 minus 1 over 2 equals x minus x over 2. 5 over 2 is basically 2.5. In order for, if someone wants to solve it without using the calculator, they can do it like this: 2.5 minus 0.5 equals 0.5x. 2 equals 0.5x and 4 equals x, because we had to find the value specifically of x. Coordinates, which means the answer should be in the form of x comma y. Now that we have found the value of x, it's not difficult for us to find the value of y. What we can do is that we can simply replace the value of x in either of the two equations. That totally depends on us. Ideally, we should do it in this one, because in order to find y, it has already been made as a subject of equation. So 4 plus 5 over 2. 4 plus 5 is 9, and 9 over 2 gives us the value of y. So the coordinates of the point of intersection are 4 comma 9 over 2 can also be written as 4.5. Alright, does that make sense?
Yep.
Question number 4 says, the diagram shows a circle with a diameter 10 centimeters. Okay, this entire diameter is 10 centimeters. Inside the circle is a square. The vertices of the square touch the circumference of the circle. Click the next button to insert a square. So when we click that button, we get a square that has been made like this. Try to consider this as the reference. Okay, now it says, show that the total area enclosed by the circle is 25 pi. Okay, area of the circle is given by the formula. Yes, area of a circle is given by the formula pi r square. Now the diameter has been told to you as 10 centimeters. So I know that diameter is essentially radius times 2, and we want to find the value of the radius. So d over 2 can be written as r. So if we divide 10 by 2, we get the value of 5. and that's the value of essentially the radius. Now, let's substitute that value into the equation. Pi multiplied by 5 squared. This becomes pi multiplied by 25, which becomes 25 pi. Alright, easy question, right?
Yeah.
Okay. Then you are told, find the length of one side of the square and write your answer as an exact value. Okay. Essentially, something like this. So let me just, take the screenshot of this. Have I taken it correct? I think so. Oops. All right. Let's consider it like this. Find the length of one side of the square. Um, this is a right angle triangle being created. Have a look. This. I always tell my students, whenever you see a right angle triangle, three things should come into your mind. The first thing is the Pythagoras theorem, trigonometric ratio, and the uh, area of a triangle being equivalent to 1 over 2 multiplied by base times height. Now, trigonometric ratio and area is not applicable in this case because they haven't told us the area, they are not talking about angles. So the only option is side, and for side we have the Pythagoras theorem. So I can say that, let's call this value L, and let's call this value as L as well because both of them are squares essentially. So can I say that L square plus L square should be equal to 10 square, considering we have the Pythagoras theorem, right? So if that's the case, I can say 2L squared equals 100. Then I can say L squared equals 100 over 2, which is 50. And in order to find L, okay, be very careful. This is the mistake that each and every student might make, even 7 graded students make. It says write your answer as an exact value. Exact value can either be in a non-recurring decimal. For example, a non-recurring decimal, I'm teaching a concept now. For example, 2.5, 7.3, finished. Nothing apart from that. Exact value can either be in a fraction or it may either be in a surd. Sometimes you might have answer as, for example, 49 divided by 3. Now this rounds off to 16.3334. But if someone writes 49 over 3, that the answer is considered correct. But if they write 16.334, the answer is going to be considered wrong. Why? Because 49 over 3 is a specific value. 16.334 is a recurring decimal. It's not a non-recurring decimal. Okay? Be careful in this regard. So it says write your answer as an exact value. L squared equals 50. I know that the value of L should be equivalent to under root of 50. But once again, that's not our simplified final answer. Under root of 50 can also be written as under root of 25 multiplied by under root of 2. Same logic, right? Under root 25 can also be written as 5. And multiplied by under root 2 remains same. That becomes simply 5 root 2. Does that make sense?
Yep.
Great. So essentially, I can say that the value of length is equivalent to 5 root 2. In your marking scheme, it's written if a further step is showing 7.07 dot dot dot, which means there are furthermore decimal places, do not award mark, which means that it should be exact value. Should we move forward now?
Yep.
Okay. Calculate the total area of the green shaded segments that do not include the square. Write your answer to one decimal place. Okay, this is part C. All right. Hmm. Area of the green region. Now, logically speaking, I can say that, let me, okay. So, area of green part can be found in one way. What is that? It could be area of circle minus area of squared, right? Simple, no need to make it more complicated. So I know that the area of the circle is going to be 25 pi as we calculated in the very first part. Okay. And the area of square should be equal to L squared. But we just found the value of L square in the previous part. We knew that L square is equal to 50. So I can say that the area of the green region can be essentially 25 pi minus 50. So if we were to solve it, 25 pi would be somewhere around 76 or 77. 25 pi is 78.54. It's 539, but essentially I'll just, relocate it to one number and then 50. So if we subtract 50 from it, we get an answer of 28.54. And because it should be rounded off to one decimal place, it should be 28.5. Then it says, find the circumference of the outer circle. So essentially what we have to do is we have to find the circumference of this region. So that's pretty easy. Circumference is essentially equivalent to 2 pi r. The radius was given as positive 5. Um, Wait a second. Okay, write the first one down, then we'll solve the next one. Okay, there's something that I have missed in this part, which was not given in this circle. So basically, there was an outer circle as well. There was an outer circle as well. And what happened in that circle, what was different as compared to this one, was the fact that it had an additional radius of 15 centimeters additionally. So in that part, the total radius was supposed to be 25 centimeters. All right. So it says find the circumference of the outer circle. Because this is not a software, right? This is just a PDF. So we cannot see that outer circle right now. So the answer would be for that C equals to 2 pi radius, which was of 25. The value of C becomes 50 pi. So that was it. This was basically question number 4. Make sense?
Yep.
Find the maximum height achieved by the ball. Okay, this was a somewhat of a difficult question to understand, but I'll help you understand it. You don't have to look at this video. Sometimes na, what they do is that they make sure that students watch a video, and students tend to think that, oh, there might be something valuable information in that video, but essentially it's not always like this. So let's check. A ball is kicked from 0, 0 towards the posts and describes the path of a parabola as shown in tab 2. So basically, what was happening was that this is a parabola, right? We understood it when we were studying quadratic equations. Parabola is a sign, it's like a shape that is made by a curve, of a quadratic curve essentially. And this trajectory looks familiar as a goal being hit from a specific position. Like, for example, if there is a player who is being scoring, like, for example, a free kick, right? Or a penalty kick or whatever. A penalty kick is not like 26 meters away, but a free kick would be a good example. So, and these are the goal posts. And we have been given a few formulae as well. Discriminant solutions. Discriminant is not in your syllabus, it's in the extended syllabus. Solutions of a quadratic equation, basically the values of x essentially, and axis of symmetry of graph of a quadratic function. Axis of symmetry, they tend to make it very complicated. Axis of symmetry is a complicated way of saying midpoint. Because of course, midpoint or turning point, or what was it called? Vertex point, maximum point. These are all the same, different names of the same thing. Okay, you see. So it says the height in meters of the ball above the ground are given by the function h of x equals x into 30 minus x over 25. All right. Mhm. So question number 5 part A says that we have to find the maximum height of the ball. The maximum height the ball has reached, essentially this one, h of x. So using this formula, how to find it? The equation was given as x into 30 minus x over 25. Now, essentially, we know that looking at this graph, the answer should lie somewhere around 15, without a doubt, right? But I know that the values of x, there are two possible values of x. One value of x is going to be 0 at the start, and one value of x is going to be 30. I can visibly see that the point where the line, where basically the distance from the kick, this is the distance from the kick on the x-axis, right? Now I have to, what I have to find is essentially this value, the maximum height that the ball reaches in vertical position. Now we can see that when does it reach the maximum? When the x value is of 15. So let's substitute x in this position, in this equation. So if I write 15 multiplied by 30 minus 15 divided by 25. That becomes 15 square divided by 25. 30 minus 15 is 15 as well, so 15 multiplies with 15. 15 squared is 225. And 225 being divided by 25 gives me a value of positive 9. Make sense?
Yeah.
So always remember that the midpoint of a parabola, sorry, midpoint, I'm saying turning point of a parabola is always the symmetry line, or basically the point where the parabola starts to turn in a different direction, right? So this is what needs to be considered. That was part 1, part A. Part B says, using the equation, show that the team scored points. Scored? Okay. It says here, to score points, the ball is kicked from 0, 0 and must go over a bar on the post that is 3 meters above the ground and 26 meters away from the ball being kicked. Okay, okay, great. Okay. So how to prove? Look, considering that the condition to meet is that the ball should be at least 3 meters above the ground and 26 meters away from the point where the ball was kicked. So, yeah, look, in order to score a goal, you should be at this point, at 26. Let's substitute the value of x as 26. 26 multiplied by 30 minus 26 divided by 25. 26 multiplied by 4 over 25. This becomes 104 divided by 25. That gives us the function h of x. H of x is essentially the height in meters above the ball. So h of x is being represented as the y-axis. Y, the height, and x-axis being represents the distance from the kick. So if we were to solve this part for h of x, we get a value of 4.16 meters. And it says it should be 3 meters above the ground at least. So it's already 4.16. So since 4.16 is greater than 3, we can show that the point has been scored, right? The height of the crossbar was 3 meters and the ball has successfully cleared the post and the scored and the person has scored the points. Make sense?
Yeah.
Okay. You see, this h of x thing is called basically functions. We'll study functions in some detail, but h of x or f of x or g of x or whatever letter is used, it shows it's a fancy way of writing y. That's it, nothing else. So this was question number 5, part B. Later in the game, another kick is taken from the point x comma 0 towards the posts. This time the height of the ball above ground is represented by the function g of x. Just another fancy way of writing y. And g of x equals to minus x squared plus 30x minus 125 over 25. Now notice that it says solve for g of x equals to 0. So essentially what we have to do is we can write this as 0 equals minus x squared plus 30x minus 125 over 25. So 0 multiplied by 25 becomes 0 as well, right? That becomes directly 0. So we don't have to worry about 0. I can say 0 equals minus x squared plus 30x minus 125. And I want to, make sure that I have a positive x squared value. So I take the entire equation towards the left. I get x squared minus 30x plus 125 equals to 0. Now we essentially have, when it says solve a quadratic equation, what do we have to do? We have to find the values of x. We have to essentially find the values of x. So let's find those values of x. 125. 125 can be written as 125 15 multiplied by 2. No. 15 multiplied by 6 is 90. 15 multiplied by 8 is 120. Wait, what factors can be used? 25 times 5. Oh, yes. 25 times 5. Then, let's write it like this. X squared minus 25x minus 5x plus 125. You should know that we have to manipulate it in such a way that we get an answer of what? We get an answer of minus 30. We take x as common, and within the bracket we have x minus 25. We take minus 5 as common here, and within the bracket we have minus x minus 25 yet again. So we are essentially getting two values of x. The bracket can be written as x minus 25, x minus 5, and the real values of x are 5 and 25. So the distance from the point where the shot was taken was of 5 and 25. Essentially, I can say that if I want to project this on a graph, it's supposed to look like this. Look, this is 5 and this is 25. Okay, and the shot would have gone somewhat like this. Let me use it in a different colored pen. Make sense?
Yeah.
Great. Did the team score points? Explain your answer. Look, realistically speaking, there are two ways to prove that the team did not score points. How? The first method is to see that in order to score the point, the ball is kicked from 0, 0 and must go over a bar on the post that is 3 meters above the ground and 26 meters away from the point the ball was kicked. So the ball has to travel a distance of 26 meters. Okay? Did the ball travel 26 meters? In the second case, it did not, right? It traveled 25 meters. So I can say that the team did not score points. Or another way of proving it was using the curve that I created. So look, this was the goal post at 26. Here was the shot being blocked. So I can say that the team did not score points. So we must write this as no 25 is less than 26. So no point scored. Make sense?
Yeah.
Okay. Question number 6. Wait, how many do we have? Oh, we still have half of the paper left. Goodness me. That's a lot of questions, man. Okay, let's just scale ourselves up a bit. Music is a widely accepted form of artistic expression and creativity. In this question, you will be presented with the instrument design of a piano. So there are some notes, and it has a specific frequency. If you studied um, physics and especially the topic of waves, you should know that the frequency is basically the number of oscillations at a specific given time, right? So this is not important as far as the question is concerned, but let's see. Um, each and every octave has a specific note, and each and every note has a specific frequency in the form of hertz. So octave 0 can be represented as a note that has a frequency of 27.5. Then octave 1 has note as described by notation A1 and frequency is 55. So 6 part A says write down what happens to the frequency F as the octaves increase. Now we can see that as the octaves are increasing by one value, the frequency is doubling, right? So 27.5 multiplied by 2 is 55. 55 multiplied by 2 is 110. 110 multiplied by 2 is 220. So I can say that frequency doubles. That's the first thing that I can say. Write down the frequencies of A4 and A5. Now, logically speaking, A4 was supposed to be here and A5 was supposed to be here. And let's just make it like this. This was octave 4, this was octave 5. This should have been twice, that becomes 440. And this should have been 4 twice again, that should have been 880. So essentially what we are saying, as the octaves increase by one value, the frequencies increase double. Deduce that all the A notes on the piano are within human hearing. Okay, now you see, humans, they can hear between 20 and 20,000 hertz. Okay, they can hear between 20 and 20,000 hertz. So that's the criteria for humans. And we have values given up till A6, A7, up till A7. This is the point of A7. I know that A5 was 880. So A6 is supposed to be 880 times 2, which I think becomes 1760. Then A7 is supposed to be 1760 times 2. If you to use a calculator, we would get 3520. So the maximum possible note on the piano was A7, which is 3520 hertz. So I can say that max note was of 3520 hertz and minimum note was 27.5 hertz. Both are within range of 20 to 20,000 hertz of human hearing. Alright, that's how we're supposed to construct our answer. The frequency f3 can be written as f naught multiplied by 2 raised to the power of k. Calculate the value of k where k is an integer. Okay. Um, F3 and A3 are essentially the same thing because both of them represents notes. So you see that's what they do. Sometimes in quadratic equations, another way of them manipulating us is that sometimes in quadratic equations, they're going to give us a quadratic equation that looks like this. Z squared plus 6z plus 9. And people were like, we just studied x. From where did z come from? That's what they do to confuse you all. So you shouldn't be confused. It's just the same thing. So F3 is essentially the same thing as A3. It says that F3 can be written as F naught multiplied by 2 raised to the power of k. F3 is written as 220 and F naught is represented as 27.5 and that should be represented as 2 raised to the power of k. 220 should be divided by 27.5 to give us the value of 2 raised to the power of k. So if we were to divide 220 by 27.5, wow, we get an answer of 8. So 8 equals 2 raised to the power of k. What number do we multiply with 2 itself? It is a several number of times that we get a final answer of 8. Of course, that number is going to be 3. Why? Because 2 multiplied by 2 multiplied by 2 equals 8. So I can say that the value of k is going to be positive 3. Alright,
Yep.
that's how it's supposed to be done. Find a formula for f in terms of n. Okay, so the formula for an arithmetic sequence is given by a multiplied by r raised to the power of n. Now, a is supposed to be the principal term or the first term of the sequence that becomes 27.5. R is the common ratio. The common ratio is basically next term divided by the previous term. So that value is supposed to remain common, right? It's supposed to remain same everywhere. So we have 440 divided by 220 or 220 divided by 110. We get the same value of r as simply positive 2 and n raised to the power 2 raised to the power of n as it is. So that's how we find the value of 27.5 multiplied by 2 raised to the power of n. All right,
Yep.
let's move forward. A note has frequency 28,160. Is it an A note? Justify your answer. Okay, this is a very critical question. Usually, whenever it says justify your answer, you have to use an example of the previous part, 27.5. Okay, and so basically this part is the one that's supposed to be used. So in order to solve this question, I have to see that what value do I get for n when I substitute these two values. What do I mean? 27.5 multiplied by 2 raised to the power of n should be equivalent to 28,160. I have to see, does n have an integer value or does n not have an integer value? If it has an integer value, then yes, that the answer is correct. But if it does not, then the answer is wrong. So let's do it. 2 raised to the power of n equals 28,160 divided by 27.5. If we solve it, we get 2 raised to the power of n equals 1024. Now, up till here, we get it right. But is n a correct answer? Now, this part can be done in two ways once again. Either it should be done through logs, which most standard math students don't know about how to solve questions using logs. They should, generally speaking, but unfortunately they don't know in most of the times. Either this question should be done through logs or it can be done through trial and error. So let's substitute specific values of n. Let's substitute n equals, let's say, 5. If we substitute n equals 5, so we get 2 raised to the power of 5, that equals to a very small answer of 32. Very small answer. If we substitute 2 raised to the power of 7, we get 128. If we substitute 2 raised to the power of 9, we get 512. If we substitute 2 raised to the power of 11, we get an answer of 2048. Now you see, we need an answer of 1024, and that answer should be between these two numbers, 512 and 2048. But what could we manipulate? The power of n, right? So let's try to put in the value of 2 raised to the power of 10. If we substitute 2 raised to the power of 10 on a calculator, we get exactly 1024. Right? We get exactly 1024. So the question says a note has frequency 28,160 Hz. Is it an A note? The answer should be yes, it is an A note, as n gives a perfect whole number this frequency represents octave A10. I hope this was, I know
Yeah.
this is not an easy paper. A new design for a piano will contain all of the A notes within human hearing. Use the information provided in the tabs on the left to discuss the practicality of the new design. for the piano, in your discussion, you should identify the relevant information for the new design, calculate relevant measurements for the new design, justify your degree of accuracy, and justify the practicality of the new design. So a new design is being made, right? And it has a few keys, it has a hearing range and an arm span. Most of the time, that's not really uh, necessary. Okay, what do we know about uh, relevant information for the new design? Now, for the new design, we know that it should be within the human hearing range, right? It should be the human hearing range. That hearing range is of 20 to 20,000 hertz. There's no need to write the answers in more detail. You can do that individually. Let's just discuss this question for now. That range is 20 to 20,000 hertz, and that should dictate the necessary structural scale. Okay, that should be the one that dictates to what extent notes should be specific or specified. Okay, now let's talk about a few calculations. If we were to continue with those notes, let me perhaps, okay, if we continue those notes further, think about this. Oh my god, why am I not doing it correctly? Okay, this won't be removed. Let me do it in a better way. So let's say this is octave 6, octave 7, octave 8. Let's just extend it to a certain degree. Octave 9. A6, A7, A8, A9. This becomes 1760. Then we have 3520. Then if you were to multiply that by 2, we get 7040. And then if you were to multiply that by 2, we get 14,080. And if we were to multiply that once again by 2 until we reach octave 10, so we get 28,160, the one we got in the previous part as well. All right.
Yeah.
So we can visibly see the result of those perhaps calculations. Then what can we do about it? Okay, we have found the necessary calculation. Then what? We can see, and we perhaps must know, that if we were to extend this geometric formula up to a specific value, up till 810, it's going to pass the necessary threshold. So we should know that the piano created should be within the category of this threshold. Okay, this is the calculation part, which we can see, which we could have done using this value as well, but still, I drew the table for information. Justify your degree of accuracy and the practicality of the new design. All right, think about it like this. You see, these extra octaves, they need to be increased. Okay, uh, they are required. But when they are going to be present on a specific piano, what are they going to do? They are going to require um, adding significantly more keys towards the left and right of a regular piano, so they should be dispersed. Okay, at the same time, when they should be dispersed, they should also be within the range of the human arm span, which is necessary for the piano to perform its tasks, right? So what we can say about them, that look, without a shadow of doubt, 7 octaves are good enough, but still they can be increased to somewhere around 9 octaves, because that's up till the human hearing of 14,080 hertz of frequency. But if we are increasing a few more octaves, what we should do, what we can do is that we can increase number of keys on different ends, making sure it's within the total arm span. All right, all right. So question number 7 says ancient civilizations built pyramids to express cultural identity. In this question, you will make calculations for a model of Chichen Itza pyramid. Where is this located? Okay, I don't know where is it located. This looks like Egypt and some parts of the Far East, probably. Maybe Malaysia, Indonesia. Let's see. Chichen Itza pyramid is composed of 9 platforms. The width of the first platform is 55.3, and on the ninth platform there is a temple that is 6 meters high. Okay, all lengths are given to the nearest centimeter and angles are to the nearest whole degree. You are planning to construct a scale model of the Chichen Itza pyramid and will use 1:100 as scan for your model. Okay, great. So we have a total of a few specifications. We know that the real pyramid width is of how much? Or the first platform is 55.3. There are 9 platforms, I think, total. Wait a second. On the ninth platform, one, two, three, four, five, six, seven, eight, 9. These 9 combined give us a height of 24 meters, and the last one is individually 6 meters high. All right. We also know that um, wait a second. Okay, so what else do we know about it? Have they given us a specific value of an angle or no? No, they haven't actually. Oh, okay, they have actually here. So question number 7 part A says, use the diagram in tab 1, determine the total height of your model pyramid including the 9 platforms and the temple. Write your answer in centimeters. So I know that the total height can be written as 24 meter plus 6 meter, that is of 30 meters, right? But all at the same time, seeing this, in that's the reality. But we have also been given a ratio of 1:100. So when a ratio of 1:100 has been given, I know that 30 meters multiplied by 100 centimeters over meters can give me the answer of 3000 centimeters. And because the ratio was of 1 to 100, this 1 to 100, this has to be divided by 100. So that's essentially equivalent to 30 centimeters. So that's 7 part A for you. Then it says, using the diagram in tab 1, find the height of each platform in your model. Write your answer in centimeter correct to 1 decimal place. So, wait a second. There were 9 platforms like this, and the 10th platform was 6. So it's talking about specifically the first 9 um, of each platform. It's not talking about the last one. So I know that 24 needs to be divided by 9. 24 divided by 9. If we were to solve it on a calculator, we get an answer of 2.667 centimeters. And if it's correct to 1 decimal place, so let me write it to 1 decimal place, that's 2.7. Alright, so that's 7
Yep.
part B. Then it says the average inclination of the slant is 53 to the nearest degree. We just noticed that. Yeah, we do. We know it. Using the diagram in tab 2, find the depth of each pyramid step. This one. Now, I know that we have to calculate the value of the depth, right? So this depth is going to represent the base. And this h is going to represent the perpendicular. Be very careful with what you label. Okay? This is going to be considered the perpendicular. Now, which trigonometric identity links base and perpendicular with each other? Sine, cosine, tan. We know that tan equals perpendicular over base. And the perpendicular value is basically h, which we just calculated in the previous part, that was given as 2.67. We should use 2.7 as we wrote the final answer. So let's write it down. Tan of 53 equals 2.7 over base. Base equals 2.7 over tan of 53. So if you were to solve it, I am getting an answer of 2.03. Alright, I am getting an answer of 2.03. Let me just bring this entire working down. Oops. Alright, that's going to earn us our mark. In fact, not just 1 mark. Write your answer in centimeter correct to the nearest whole number. Oh, okay, I just missed out on this one. So, in order to convert this up to the nearest whole number, our answer should be rounded off, and that means the answer should be simply positive 2, right? So, our answer should be essentially equivalent to positive 2. Then it says, using the diagram in tab 1, find the width W9 in centimeters of the top platform in your model. What, didn't we just calculate it? Oh my god. We have to find this width essentially. Okay, what's so different about this one? Wait, how do you do this one? Now, I know that basically the bottom width is 55.3. Okay, which is 55.3 meters, and that's numerically equivalent to centimeters as well. Now, okay, this is a bit difficult to understand. Now, have a look. In order to go from this step to this step, 1, 2, 3, 4, 5, 6, 7, 8. You have to climb a total of 8 steps. Okay? You have to climb a total of 8 steps. At the same time, I know that these tapers that pyramids have, these tapers that pyramid have, they're actually symmetrical to each other on both sides. I think they gave us some relevant information here as well. Did they? Fascinating. No, they didn't. What sort of a question is this? I get so confused. Right, no worries. Now I know that the the original length was of 55.3 centimeters, right? So at the same time, I should be well aware that this pyramid is symmetrical on both sides. So I must subtract the depth twice for each and every step that I'm going. So how can I write it? I can write that the width of part 9 is equivalent to 55.3 minus 2. Why 2? Because I'm going to subtract for multiply for the depth twice, multiplied by total of 8 steps taken. And each height that we just calculated is of roughly 2.03 centimeters, right? So if we were to calculate it, what answer would we get? If I calculate it, I get an answer of 22.82. This is how I'm going to find the answer. Does that make sense? This was a difficult question, so I can explain it again.
I got it.
Okay, just to quickly explain it again, quickly. Look, without a doubt, we can see that there are 8 steps that need to be taken, right? These are the 8 steps. Now, what happens is, just like normal stairs, the value of the tapers, these are the tapers, right? They are decreasing from both sides. So you have to subtract that width. You have to subtract that width. But as you subtract that width, you have to multiply that value by the height because height remains constant. So that's how we made this formula and we got the answer of 22.82. This was a very unique question, honestly speaking. This the first time when I was solving it, I got too confused. Discuss the validity of your model for Chichen Itza pyramid. In your discussion, you should identify relevant information required to discuss the validity, consider the implications of the chosen degree of accuracy, comment on the validity of the model to the Chichen Itza. Okay, first things first. Relevant information required. What things are required to discuss when we are talking about the validity of our diagram? The first thing that we can talk about is um, the proportions. The proportions of the pyramid. We can also talk about um, the dimensions, the vertical dimensions, which is the height of 2.03 centimeters, vertical dimensions. And we can talk about 53 degrees of angle inclination. So this is the relevant information that needs to be known, first things first. Consider the implications of the chosen degree of accuracy. All right. Do you remember when we were solving this part, our final answer of D that we found the depth was 2.03, right? 2.03. But we did not write it as 2.03. We wrote our answer as 2. Now think about this logically. There are a total of 8 steps, and those steps are decreasing symmetrically from both sides. So I can say 8 times 2. What's 8 times 2? 8 times 2 is 16. So what I'm doing is, the original depth was of 2.03, but I'm mentioning it as 2. Can you multiply 2.03 and with 16 and then multiply 2 with 16 and tell me what both answers do you get? 2 times 16 is 32. Can you tell me what's 2.03 multiplied by 16?
I got 32.48.
32.48. Okay. Now you see where is the problem? Now we are missing out on 0.48%, 0.48 centimeters of information. 0.48 centimeters of important information. Now, 0.48 centimeters of information on a graph is equivalent to roughly 0.48 meters in real life on the model, right? Because we talked about how the numerical values are going to be same regardless of their units. Now, what is the problem? 0.48 meters is roughly half of a meter. And when half of a meter, like, because half of a meter is a big information, right? It's not something negligible, it's not something small. When half of a meter has been removed, that error, when it is multiplied across 16 structural step edges, this creates a big variance of 0.48 meters at the top platform width. Make sense? So this is the implication. This is the problem. Implication basically means the problem or the negative effect. Okay, so
Yep.
we can say that 0.48 meters is too much, right? It's a lot of information that has been missed out on. But let us comment on the validity of the model to Chichen Itza. Now, realistically speaking, let's evaluate between what we have. First things first, it was for an educational purpose. Educational purpose, right? Secondly, we know that all of the layers are correct. We know that angle of inclination is also correct. The only thing that is problematic is the vertical, sorry, not the vertical dimension, the value of h, and that too to a very negligible extent. Okay, so I can say that, um, is the model good or bad? Because at the end of the day, it just comes down to these two things, good or bad. So I can say that yes, although there is some problem when it comes to a total height of 0.48 meters, regardless of that, it serves an educational purpose. Its layers are correct, its vertical dimensions are correct, the proportions are correct, the angle of inclination is correct. So that mistake that they have is very, very negligible. Like, it's okay, it's fine, it's a small error, that's fine, we can work with it. Make sense? So
Yep.
that's how we can prove that, um, the idea being discussed is essentially valid. I hope this makes complete sense.
Yeah.
Great. This question number 8 is of essentially 20 marks. Okay, so only question number 1 was left. Let's solve it now. So it says, this is basically one part. A says, write down the equation of the line that reflects shape A onto shape B. Now, looking at this, you see, this is the shape, these two are the shapes, and this is the line that's reflecting them. So, without a shadow of doubt, we can see this in a very crystal clear manner, that the line in which it is being shown is the y axis. But if someone writes the answer of y axis, that's not going to be considered correct. Why? Because we have to give the equation. So the y axis has the equation as x equals to 0. So that would be the right answer. Then it says, okay, no. Translate shape B by vector 8 to, draw the label and the new shape C. Next, reflect shape C in the line y equals to 1 and label the new shape D. Great. How to solve this part? That's pretty easy. 8, 2. 8 values towards the right and 2 values upwards. Let's focus on this part. 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5, 6, 7, 8. And 2 values upwards. 1, 2. So, our point where this region should exist should be this one. Oops, wait a second. This is going to be shape C. And then it says reflect shape C in the line y equals to 1. So the line of y equals to 1 is essentially this line. So if it has to be reflected, let's reflect the way it should be done. So this is a length of 2 values. So here it should also be a length of 2 values. One, 2, and it's going to go one value towards below, like this. Alright, so that's how shape D is going to be constructed. Describe fully the rotation that maps shape D to shape A. Now we can see, in order to describe the rotation, it's quite evident. How? Have a look. Without a shadow of doubt, it's a 180-degree rotation. It is a rotation of 180 degrees. But we have to be very careful where the point of rotation is. The approach is that we take points that are opposite to each other and we tend to rotate them. So the point where it's intersecting the x-axis is 4, 0. So I'll write rotation is of 180 degrees around 4,